Alive? Yo. Let's open it up. Let's go to the J-Den. Oh, fucking wrong. I am live. Hey.
So if I type something here, test.
Let's open it up. Let's go to the
Yeah.
Oh, fucking wrong. Alright. It's time.
Let's give streaming on YouTube a shot. I wonder if there's a way for me to see this chat, like, just always on my screen. I don't really know. Well, let's keep it going. One more thing. Let's disconnect here. And alright, nice. J-Den live, how to YouTube chat. I feel like this isn't the right chat. There we go. Want to see this? Close. Exit. Stop. Alright, I want to get the chat. So let's pop out the chat. Hey, there we go. Alright. And I have this pop out. So maybe I could bring this pop out over here. And we can do it like this. Do it like that. Let's bring this here. And we'll bring this chat like this. Move this over here. And make this a bit smaller, maybe. This. Wonder how that looks. System looks pretty normal now. If I could see chat here. Is that what I want? Also put the chat over here. Think maybe I can duplicate this. Yeah, let's do like that. Bring this over to desktop 1. And is there a way for me to duplicate this or no? Just like this. Nice. We're gonna go with that. Same thing over here. Can I... I done broke my whole thing. Come on now. Yay. My goodness. Alright, screen, we can see the thing. And we can read. Cool. Let's do it. So to finish up having a code, actually let's also post this on, let's post this on my socials. So let's take this link. Alright. Posted to some friends. Let's put it on Instagram too. Then be done.
Cool. So, for problem, we have 2 stars left, 24 and 25. I need to do part 2 of 24 first. And it tells us, what does it tell us? I should keep Discord open. Keep Discord open. Go to Discord. Go to discussion. Can I do this? Hello? Hi? Maybe? Can I share my screen? Try this one more time, and if it doesn't work, go back to what you were doing. Come in here, discussion, join voice, share screen. Alright. Streaming on Discord as well. So for part 2, they tell us, after inspecting the device more closely, you determine that the system you're simulating is trying to add 2 binary numbers. It's treating the bits on the wire starting with X as one binary number, Y as a second, adding them together. The output is produced as a binary number on the wire starting with C. The initial values for the wires in your puzzle represent just one instance. Yep. Okay. Many more bits, it therefore has many more wires. Based on forensic analysis of scuff marks, you can tell that there are exactly 4 pairs of gates that have been swapped, causing the system to produce wrong answers. By sorting their wires' names and joining them with commas, much more complex if you were determined that you need to swap out. 8 wires total are in the wrong place. 4 pairs are swapped. Determine which 4 pairs need their output swapped. What do you get if you sort the names of the 8 wires involved in a swap and then join the names with commas? So we have a half adder, I think, right? Two single bit diner. But we have multiple bits. Get our sum and our carry. So that's something too. Let's look at how many bits the output has in Z, right? What was I doing here? We have first and second. Yep, A, B, and wire val. Wire val, wire val, wire val. A, B, and. Alright, for part 2. I should rename this, I don't know. I don't know. What to name it though? Let's rename it. Expressions, something. So my first thought is that we should just look at how many Z values there are and see if we can infer anything from that, like if there's a carry or not. So to do that, I'm going to get rid of all this because I don't remember what I was doing anyway. And I'm going to say for each A, B, and end in expressions, start Z. I'm going to collect a list. And I'm going to say if A dot starts with Z, and then starts Z dot append A, and we'll do the same for, let's see, for gate in A, B, and end. If gate that starts with Z, then we'll take our gate. And then we're just going to print all the starts with Z and see what we see. We also want to make sure that we sort it. So that's a little easier for us to understand. Let's go to day 24 and let's run it. So we have up to Z45. If I'm adding two 44-bit numbers, right, all the way up to 44, at 44 places, and then 45 is my carryover. So I have a carryover as well. Swap, I sorted it up as far as names, yeah. Combining the bits. Z0 is the least significant bit. So Z45 would be our carry and not Z0. Okay. So now that I know that there's... Oh man, what do we need it to look like? It's going to be a bunch of XORs basically, right? We need to say each Z0 is going to be X0 plus Y, XOR Y0. And then the carryover bit is going to be what? The carryover bit is going to be X0 and Y0. So basically what we need to do is we need to say, let's come over here, let's kill this, what? So for our notes, we know Z0 should be X0 XOR Y0, and we know Z01 should be X01 XOR Y01 XOR. We know XOR essentially acts like addition mod 2, is why I'm using XOR like this, right? So we can just perform our addition bitwise, but instead of using addition, we use XOR. And that'll keep us from having to worry about carryover. Right, so the value of 0, 1 will be determined by the value of x1 and y1, and if there's a carryover bit from z0, which would be x0 and y0, like that. And then for z2, we would add the bits from the 2, but we would also need to see if there's a carryover from z1, and that would happen if what? Let's see if we can look this up. That's nice. Stupid. All right. Ah, I see. So we XOR all of these C in to get the sum. And then C out equals what? We have A dot B. What's dot? Oh, it's an and. A and B. Yeah. Okay. So we know that C out will be A and B plus C in and A or B. So in this case, our A or B was, let's see, our C in would be 0. A and B. Like this. And then plus C in and A or B. So I'm gonna say initially C is just 0, like this, and then this would be XOR C, and then this will be plus C and X0 XOR Y0, like that. Just like that. And then we should see something similar for all the rest, right? So for Z01 and C01, we should get C0 here. And this should be 1s. These should also be 1s. This should be 0. And this should be 1. Just like that. Then I think we repeat, right? We just do this forever. We say This should be a 1. This should be a 2. This should be a 2, 2, 2, 1, 2, 2. And we do this all the way till we get up to the end. In which case, instead of C45, it should go into Z45, right? And this would be C44. Then we have, this is 44. This is 44. This is 43. Same thing here. This should be 44. This should be 44. 43. 44. 44, like that. So how can we verify that this is correct? Let's look for x00. x00 and y00 are going to MGK. So then MGK is an intermediate for this. Oh no, it's for the carry. XOR and so this might be doing the carry right here. Let's look for x00 again. x00 XOR y00 is going into z00. Sounds right. Because this is initially 0, right? Which means that it's equivalent if we just omit it. Okay. This looks right. How about where is Z00 used? Oh, that's it. Okay. So our carry for the first bit is MGK. It looks like our carry for the first bit goes into, uses this thing called RKF. What is RKF? Right here. X0 XOR Y0. So this is our second bit right here. Our second bit plus our carryover bit is our... Okay, this is doing what? So how would I programmatically tell that this is like wrong or right? This looks right so far. How do I know? C02 is getting these two. Do they all work like this? Do they just have one tail end that pipes into them? Okay. So then one way we could tell is we could just say, are the derived values correct, essentially, right? It doesn't necessarily tell us how to swap, but it'll tell us which ones are wrong. And then maybe we could just try... Let's see. I feel like I'm getting somewhere. Not sure yet, though. Let's come back over here. So, what do these represent? Val of y equals this. Where's or coming in? Oh, this is a or. Is it? Yeah. Okay. So this is an or. Let's come back to here. Like that. Let's see, where's the first or used? So this would be our carries. Our ors indicate our carries. Right. MGK. Is it used in or anywhere? No. How about No. RKF. Is RKF used in one? And XOR RKF. So it does say we could replace the XOR with the OR with XOR, and it will still work. So maybe it's only using it sometimes. It's a little weird. You know something we should try? Let's see if it really is equivalent. It should be true that we could replace this with XOR and it'll work just fine, right? That's what it's doing. So let's run this again. We get a number. Let's run it like this. See if we get the same number. Yes. Okay. So we can essentially replace all of our ORs with XORs and not have to worry about it. That's nice. So all these ORs don't matter. That's kind of cool. We can backtrack through the wires to get the values using this op map, just like up here. Let's just compare the bits. Excuse me. But so here, when we have our wires, we'll say we want to say reverse equals true because it was little endian. And we also want to print bin of num1 plus num2, right? So what's num1 plus num2? Num1 equals we want to see the int of get val of wire for wire in wires if wire that starts with X and same thing over here with Y. We want to make sure that we map all of these to stir and do it in base 2. What's going on here? This is ridiculous. Come on. Maybe let's call this num1 stir, like that. And one more thing is we want to sort this again because it's little endian. No. Sorted to get valid wire for wire and wires. Wire starts with X. Let's also get the Y and X files like this. It'll be a little easier. And you can do the same thing here. And put S Z slash Y slash G S slash C slash X dot slash G, just like that. And now what? Now we can say Z vowels, X vowels, and Y vowels can do the same thing. Just like that. So C, num1 is going to be int of just like that, and num2 It's going to be the same thing, except we need to go find x and replace it with y. Then we have our sum is equal to num1 plus num2. And then we want to print bin of sum, but only up to 2 characters after, because it's going to have a 0x in front of it. Like that. And the numbers are pretty similar, but they're messed up in a couple places. Right here. Oh, it's quite a few places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The carry's getting messed up somewhere. So we should look at the first one and see what's messing up with the first one, maybe. And then we can sort of trace it back up. So the first place where it messes up is here. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's not do that. Let's say that. Zip these together. Okay. So the first place where they differ is 14. That sounds about right. This looks like it's about the 14th one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, oh man, what do we... Do we just try swapping 14 with something until it's correct? Something later? Ooh, that's something we know. Nice, right? One thing we know now is that all the stuff before 14 is correct. So maybe we try backtracking. Okay. How do we keep track of the ones we used? So I think this makes sense, right? We can just sort of use like an alias or whatever. So we'll have each wire mapped to itself initially, and then we can swap them out when we're backtracking, right? So wire to wire for gate to gate for so it's called everything. Like this. Let's just call this a set of expressions. And then let's subtract a set of op map. Like this. This should get us all of our wires and gates. But I really don't want the wires. So maybe I'll just say like that. Let's call this B. Like that. Let's try printing everything. See if it gets us all of our gates. So really, let's call this gates also. Okay. Let's print our gates. Let's see how that goes. Let's also do minus set of val of. Now we have all of our gates. So now we have all of our gates. Let's make an alias. Let's make a gate alias that just maps each gate to itself at first. Then we'll also have a used set. Now lastly, we'll do what? We want to find a backtracking function. They find backtrack of I. We'll start at I equals 0. And if I equals 46 or whatever, then we're done, I guess. Otherwise, what do we want? We want so we want to change this get val. Why? We want to say we want to use the alias here. Alias of A, alias of B, just like that. Gate alias of A, gate alias of B. Doing something wrong here. Oh. Like that. Yeah. So if it's not correct, we'll say unused equals list of gates minus used. Say for I G1 in enumerate unused, for J G2 enumerate unused. We'll swap them. Instead of enumerate unused, we'll use range. That was the whole point. For J in range I plus 1, length of unused. We're going to just try every swap and see which ones yield us a successful result. But we're going to do it in a way that's not completely brute force, so that it doesn't take forever, hopefully. So what we want to do is we want to say G2 equals unused J. Then I'll say gate alias of G1 equals G2, and gate alias of G2 equals G1. And if we can backtrack and it works, then we should return true. Otherwise, we should swap them back. And if we get through all of them and it doesn't work, we should return false. And lastly, since we know there'll never be more than 8 swaps, we should also say use.add.update G1 and G2. And use.difference update G1 and G2. And we'll say num swaps plus 1. Just like that. Actually, we'll say num swaps. We'll call it remaining swaps. Remaining swaps? Fuck. Just like that. And we'll make this a minus. And up here, if there's not remaining swaps, then we should just return backtrack of I plus 1, 0, that. And one more thing is over here. If we don't need to do any swaps, then we should check if we don't even need to do any swaps first, right? So let's try if backtrack I plus 1 remaining swaps, return true. Just like that. And I think this is what we're looking for. One more thing, so we actually need to compare the values at I, right? So if get, let's see. You do it like this, right? How to use F strings to like that. Ooh, it's not working, is it? ChatGPT is down. Yeah, okay. So I'll say x equals f x I 0 to d and same thing for y, and then if let's also find the correct values from down here, right? What was it? Yeah, I think it was we want this essentially up here. So let's grab all of this. We want to see what alias looks like at the end. So if backtrack comes out as true, that means we found a combination where all of the bits match, and then the state of alias will tell us which swaps we had to do to achieve it. Right, so over here we should say get val of x actually no, we shouldn't even be using this, we should just be using z. So if get val of z equals sum of, it's either going to be sum of I or sum of reverse I, and I don't want to think about which, so we might just not bother. Like this. Sum stir, return true. Otherwise we do this. Okay. Fuck it, let's try it. Nice. Let's use .get here because some of them won't be gates, right? And if they're not in the gate, then we should just return the original thing. So if it's a wire, then we should just return the wire. So let's call it a alias equals gate alias dot get a, and otherwise just return a. Same thing for b. And then over here we'll say a alias and Be alias. Let's try this again. What? Let's do it like that. What's going on here? Got recursion depth exceeded. Why? Get val Z. Doesn't seem a problem up here. If anything, it does it like instantly, right? I think this should be reversed. I doubt that'll fix it, but try. Yeah. Okay. So why is this? Why is this doing recursion depth exceeded? Oh, is it possible that we make it impossible by making a swap? I didn't think about that, right? It might be possible, it just doesn't even work anymore, right? So to do that, I'll have to look for a cycle. So we'll say scene equals none, and scene equals scene if scene is not none, else empty set. And if wire in scene, then we should return there is no value. So we'll say return none. Otherwise, we'll say scene dot add wire. And then when we do get val over here, we'll make sure to pass in scene. And over here, we'll make sure to pass in scene. And let's just make these a values. So I'll do get val scene here. Get val dot, no, what the hell am I doing? No, yeah, get val here. Scene. Just like that. Oh, duh. If a val is none, return none. If b val is none, return none.
I gotta get ready.
Okay. I'm streaming right now, but you have a meeting?
No. I'm just gonna get dressed and.
I'm saying I can move though. It's not a big deal. If we could see which ones are swapped here, I think this is the answer. Back in 2. So let's print out alias again, but only print out. Just hold on. Come on. So not only did that work, but that worked faster than I expected it to, which means that we should be able to get our values back if we come back down here. And let's return W for W. No, let's return G for gate and alias in gate alias dot items, but only if gate is not equal A. And let's also sort these. And lastly, let's join these with a comma. 1, 2, 3, 4, 5, 6, 7, 8. This looks good. Might be right. Fuck. Hold on. Sort the names of the 8 wires involved in the swap and then join these names with commas. So one thing obviously might also be like, let's do our comparison, see if the comparison makes sense, right? Up here. So these are our Z wires or Z values. So our result string should be the join of our Z values. Otherwise, what? We want to look at the sum.
You talking to someone or you talking to yourself?
What the hell is that? Okay, hold on. So you have sumster. Where are all these nuns coming from? Obviously from there, but like why? None, 0, 1, none. Let's come back down here. Like that. Like that. Down here, we'll say val scene equals get val of z, and we'll say use dot update scene. So if val equals this, backcheck return true. Otherwise, we're gonna say used dot difference update. Scene. Same thing down here. I think that's good. Let's try that out. Tuple and tuple. What? So this is A scene. B scene, but we don't really care, right? We don't care about these values. None set. Scene. What is this? Okay, keep going. You're almost there. These should be 0 and 0. Is this even worse? 0, 1, 0. No, we're almost there. Come on. How am I still getting nuns? N to the 8. It's really big. Are we still getting... It's changing every time too. Non-deterministic output, it's even worse. Hmm. So my suspicion is that swapping them is affecting earlier outcomes, but it's not clear if that's because of the nature of the circuit or because of a bug in my program. If it's the latter, if it's the nature of the circuit, I need to think of a different solution, but if it's a bug in my program, then maybe we can fix it. Let's look at get val again. This looks right to me. Let's make sure there's not any weirdness there. Why is that not printing? That's strange. Use the difference update scene. I see. Let's call this I, let's call this like bit or something instead. Wait, this place is bit. 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 I make this mistake often of overshadowing the I You notice we used I for this loop, but also for the parameter. It's problematic. See, do we see I anywhere else that it shouldn't be? That looks better. It's like this.
Thank you for
Now this might take too long though. We'll see. Let's try using pi 3.10 on my script. Speed it up a little bit. But we're still getting the weird nuns anyway. Where are the nuns coming from? You might use the same thing multiple times in different places. So the scene might need to be stateless. Let's try it like that. So like right here, right? Instead of saying scene.add wire, we'll say like this. New scene. Just like that. maybe it goes like this. New scene. I think I need to incorporate the ones from the returns as well, but we'll try it. I want to see that it's not getting stuck somewhere. Well, it's not getting stuck, but it's stopping really early. It's branching out really early. So I do this with dynamic programming. I feel like that might be a lot. It doesn't make sense to do. You can also just visualize it, right? Like the whole point of an adder is that it can be implemented as a circuit. But like, it'd be nice to do this more programmatically. But we could just inspect the circuit and see if the circuit behaves the way we think it should or not. If I can't get a coded up version working, I'll do that. There's also a more direct way, right? Like when I'm grabbing the value and they mismatch, then it's one of those values that is the wrong one. So maybe that's what I should be looking at, right? Like over here. Get rid of this update, but then I should be saying for G1 in scene, do this, and then for G2 in unused, which could include scene, we'll do that, but it'll be far fewer, right, when we do it this way. Yeah, you see it's changing more often now. Still a bit much though. Let's make sure that it's actually doing what we want. It's not going back to printing nuns. That looks right. let's call this A scene, and let's call this B scene, and then over here we'll return A scene, B scene, new scene, like this. Man, this is not, I don't think this is right. Gotta think of a different method. Four-digit ripple carry adder. Yeah, this makes sense. See, like, we could visualize this and see is something swapped, but quantum adders. No. Two pairs of gates have outputs that are involved in a swap. Let's get rid of the prints in part one. Make sure everything we're looking at is from part two. Yep, so when I'm printing result string and the sum string, They're sorted, which means that the least significant bit is first for both of them, right? Same for this one. Yep. That looks right. I mean, they look like they're almost matching anyway. I feel like it's getting real stuck. Yeah. We should at least be seeing the bigger ones a little bit. It's getting real stuck at 4. Wait, really? We're going to see about visualizing the circuit as a graph.
Let's look at this picture again. We know none of these gates can be wrong. But we already tried to take advantage of that, right?
So how do we turn this into a graph? We need to read documentation and go on from there, right? So looks like we sort of just say that something points to something else if we put an arrow to it. I don't know if these are draggable, but let's try it out, right? I think we could literally just say, what if I want multiple? Like, show me a bigger example, please. So maybe I'll say print digraph and print and then for each of these I'll say print A points to end and B points to end. And it might actually be backwards, but whatever, I guess, right? And then we'll return. And we'll just run part 2 instead of printing it. And so I think this could work as an input for GraphViz, right? Let's give it a shot. So now we should be able to pipe this, right? I should be able to say, man, I should know this from CTF. Like that. And then we want to put this into, I don't know. That looks horrible. Come on. But this isn't what I want anyway. I want to be able to drag them around. Is that not possible with GraphViz? Nah. This isn't the Intel. I need silicon. Yeah. Come on. Let's try it over here. Let's open a graph file and we'll find it in here. This looks pretty cool too. Let's try Gephi first. We're going to what? Preview? No. I don't want to learn all this. Do not save. See if we could open out maybe. Yeah, but how do I actually put it in? See if we can find a YouTube video that shows it or something. It's called Jeffy's again. Jeffy Graphis. Let's check this out.
Hey everyone, we're going to take a quick look. Calculates the roots of a quadratic. It's just going to be the call hierarchy, all of the functions. We see a list of them, and then we also one that does the majority of the calculation. So let's take a look.
I use G.
But these are probably static, right? Or no? Yeah, I want one that's not static. Although we could try. We could say spoiler. Maybe we could open that SVG. Let's see, let's go to projects. Solutions, day 24. I want to see what this looks like. No. Man, there's gotta be an easier way to do this. No. Maybe I just need to rename the file. I really did just need to rename it. That's horrible. Ew. You know I'm still streaming, right? It's streaming. You're online right now, I guess. I told you I was doing that.
That was hours ago.
Mom came. I told you I was doing that. Excuse me. Whoa, okay. This might be more doable. Let's find all the Z's. Alright, go with that Z. Another Z. Another Z. 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 No, this is X. Y. Z33. Z26. So let's go back to our picture of our adder. Over here. We should stack them like this. So I'll say like Z7. Y19. Y37. Y40. Z22. X37. So right here, X37, Y37. We want X01. we have 35, y35. Y32. Y33. Y30. Y39. Y40. So we have Y30, Y32, 33. Wish I could sort of just blow these all up away from each other so that they weren't so crowded. I don't know how though. Z34. Z19, Z28, Z17, there's more, Z24, Z1, Z9, let's bring out these X's, see a Z18, X, take the X out, take the X out, take this X out, we have X00, X29, X43, X30.
Wow.
Holy shit. Where are you at? It's loud. Hey.
Whoa.
Working on 24. I had a backtracking algorithm, but it was going like insanely slow, and so I said, let me just try to see if I could pick apart the circuit, because, yeah. This is also...
Wait, did you manually place these?
Well, they all just got scattered in the middle, so I'm like trying to pick them apart. I'm like, all right, the X's, I'm gonna line up all the X's and the Y's and the Z's, and then see which ones are fucking not where they're supposed to be. I feel like this is gonna take forever too, though. But I feel like the program was actually gonna take forever, like Age of the Universe forever, versus this is like gonna take forever in the annoying sense, but not actually take literally forever.
Well, yeah, the 44-bit adder. I don't think you can.
There's probably a smarter way. There has to be a smarter way to do this, though. I don't really know what it is.
There were lots of graph solutions to the problem.
Yeah, but I'm saying the guy that makes it, he always says like, oh, you can run this on a 10-year-old computer in less than 15 seconds or whatever, right? So there has to be some like way to do this programmatically that is not, you know, like stupid.
There is.
Did you figure that out, or did you use a graph?
No, I figured it out programmatic way. I think with the way the problem was designed, the programmatic way wasn't like that difficult. But I feel like you could be like giving us formulas where the programmatic way was not.
Well, because, like, so I understand that there's a bunch of, like, I understand this picture right here, right? This is our ripple carry.
Yeah.
And I was mapping some of it out, right? Like,
I think. I mean, one thing that I did that helps because my initials, I didn't write the programmatic way initially. I only did that after solving it. My initial solve was just using a couple helper functions and then just looking at the formulas and then noticing any differences between them.
well, so I was trying to manually inspect it a bit too, right? Like I had it print out the different bit strings, and I noticed, hey, it's different at bit 14, right? But even from manually inspecting it and trying to sort of narrow the work I have to do, it wasn't clear how to, like,
What was the difference at bit 14?
what do you mean?
Yes, what did you notice was different about bit 14 versus the rest?
Its value. Like what a
Wait, no, I meant. Okay, sorry. I meant what I did was I wrote down the formulas. I just wrote a recursive algorithm that would just effectively take out all of the middle variables and just give me the raw formula at the end for each bit based off of x's and y. That even that ends up being like more work than you have to do to notice differences. But like for example, if you go back to like the formulas you had before,
Like, look at this. Hold on. Fuck you, stop it. Just do this shit normally. What is going on? Am I being dumb? What am...
oh, I see it. There is backtracking. Okay, I think that also would pinpoint where the differences are.
It doesn't matter though. I don't need to do the backtracking. Here, give me a second. I need to reintroduce this loop. I deleted the loop. Okay. These are my two numbers, right? And it's like, hey, look, bit 14 is wrong. Right here. Right? And I can sort of use what I was looking at, what you were just saying, right? I could say, look, like, I know all of these work, but like...
What's the formula for Z14?
I'm gonna just have to keep backtracking through this, you know.
Just look at it in your input.
Huh?
Just look at your input and see what they use for Z14. Look at Z13 because it could be a problem with 13.1.
Oh yeah, you're right.
Actually, yeah, just look at all of the Z's and know any of them that look different from the rest. The Z45 is going to be different, but that's a carry. Z18.
This one just has directly the...
That's not how you get the 18th bit.
It actually turns out you can sub out OR or XOR for the carry bit, and it doesn't matter.
Yeah. I think that I know is just that all of them basically end with an XOR operation,
Yeah.
except for a couple of them. And the ones that don't are also just so happen to be the ones that were wrong.
So there's this one.
E8 scrolled past it.
What?
Z08. They're using AND at the end instead of an XOR.
Yeah. And 18 did too. Oh, I misunderstood the question. Two pairs of gates have had their output wires swapped. They're talking about these gates.
Yeah.
I was coding it up wrong. I don't know what I was thinking about. I was thinking that they said the wires are swapped. Maybe that's why it's so... I should be coding this differently, is my point.
Right, but like you know now that Z18 is wrong. It has the wrong input to the output. So then you know that one of the other ones has to have the right formula for Z18. And then once you figure out which one has the right formula for Z18, then you know how to perform the swap.
Yeah, so Z18. This should be going into a... This should be going into... This is our carry. This is our carry for 18.
No, the carry formula ends up being more complicated than that.
Yeah, I know. It's like, it's this shit, right?
Yeah.
But it starts with that, right?
Yep.
Then we have to do our or I was saying this could also be XOR, and it still works. But this should...
Yeah, if you go back to like... Well...
Even my graph visualization was wrong. I just wasn't visualizing this right. So, let's think about a new program. So this is our gate, I guess.
This gate is just wrong. It should be more like delete all this shit. So the gate output wires are swapped. Let's do it like this. I'm gonna say do I want to do this the same way? Sure. Expressions, I'm gonna say gate equals list of range of length of expressions. Like that. And I'm gonna say input wires equals this. And I'm gonna say for. I'm also gonna say output wire. I'm gonna say for gate and then A op B and enumerate expressions. Up a wire, and then I'm gonna say gate op like this maybe or something. Then I'm gonna say input wires of gate equals AB, output wire of gate equals end, and gate op of gate equals op. Like that. Bro, what? Something with these is fucked. That's dumb. Why did that happen? Whatever. Here we go. First of all, how many gates are there? I feel like I haven't even checked this. $222. Fuck. That's fucked, dude. What is that? Like quintillion? But we know some of the... Right, like we know the gate associated with Z18 is wrong. It's still gonna be fucked though, right? Like even okay, I know two of them, right? I know
Right.
Z18 and Z08.
Even if you know 4 of them, it's still 222 to the 4.
That's not that bad. My computer could do 2 billion in a reasonable amount of time, right? It won't be less than a second, but like it'll be okay. No.
Alright, well, you could limit it. You could further even more. You know Z18 is wrong. You know the thing that's inputting into it is wrong. Can you figure out what should input into it, though? just from looking at the input. Because they do all follow. I mean, if you look at like the adder they have on Wikipedia.
Yeah, I know that. If I reverse these, I should be able to see which one's like wrong.
Yeah.
Maybe instead of trying to track it manually, though, I should like try and see if I could like bring them all into expressions of x and y or something, and then I could see. Well, doesn't matter too much, I guess. Maybe I should just track it manually. I don't. Right, like okay, if I go to Z18. We have X18 and Y18.
Right.
So
But
you're
what
saying, what
should
should
be
this be
there?
going into? What should be here?
Yeah.
Well, let's look at somewhere where I know it's right. I know the first bit is right? So let's look at X00 and whatever. And like right here, NFW. Where does NFW get used? NFW or KMJ goes into RWP. I did this earlier. And it was annoying and I stopped. NFW or KMJ. So let's look at KMJ first.
Yeah, well, these are all going to be carry, so it's going to be in temp variables a ton.
These are the ones that I was messing with. It was MGK and RKF. MGK was the
Oh,
first
it's
one. It was Y0 and X0 goes to MGK.
Yeah, but okay, you know that the 0 also includes X01, XOR, Y01. And using the XOR is easier to track because the XORs don't go into the carries. Or
What? I know. So for Z18, what should
Or
be
no, they
there is
do, but they go through. Yeah, so you can like start out the formula for Z18 and see what it should look like.
Yeah, it should.
Because just based off your pattern, it would be like
Z18 should be like X18, XOR Y18, XOR C17.
right. So where's X18, XOR Y18 going?
FMM.
Going to FMM. And where's FFM going?
SHW.
SHW. No, that's with an AND. We don't want the AND. The full form is going to be FFM XOR something else. XOR the carry bit. So this is most likely part of computing the next carry. So where's the other spot that FFM appears? There, FFM XOR MFK. And so now I'm willing to bet MFK is your C17, and WSF is supposed to be what Z18 is.
Bruh.
Yeah, that's basically what I did for the first three, because three of them ended up with the last operation not being an XOR.
This is wrong too then. Right, because so we started at X18 or Z18, right? And we said, look, this AND is wrong, whatever, right? What should be going to Z18?
Yeah.
What should be going to Z18 is X18 XOR Y18 XOR C17. So let's look for Y18. We find the XOR goes to FMM. And so we want FMM XOR C17 going into Z18. So is MFK C17?
That's not an XOR.
It's a OR. That's fine.
No, sorry, but you don't have FFM XOR MFK. Should be FFM XOR the carry.
Oh, yeah.
So that's probably not C. So MFK is not C17. It's just part of computing C18.
Well,
Yeah.
it's
So
here.
Oh. Okay. Right. But you know, this is the part that we're going to Z18. So you know WSS is the thing that's swapped with it. And so one of your swap pairs is going to be WSS and Z18.
Well, I don't, right? Because MFK might be wrong too. MFK, like MFK and
Could be, but I don't see how that changes that specific pair.
yeah, I get what you're saying. Okay, so let's do that twice. Let's do that for, it was Z08 as well, right? Yeah.
Yep.
Hold on. WSS. So MCR MVB.
On the top there.
This one's a little weird.
Oh, yeah, that one's also wrong.
It's not necessarily wrong, right? No, it is, because this isn't the carry bit. Yeah.
Yeah, and also they all use XOR at the end, so
Y23 FWJ.
no, that's not the XOR between X23 and Y23.
That one. BMN.
Yeah.
Oh, this is stupid.
Alright,
I could
now you
have just manually inspected it the whole time. This is dumb. There's only one.
The last one. The last one's slightly trickier. This is the same as my input. 3 of them are going to have the error where the last operation is wrong. And then one of them is going to have a different error where it's a previous operation that's wrong and not the last operation. So I believe you have caught all the ones that have an XOR, that have the wrong like XOR operation at the end. Technically now, once you swap those two, you could just brute force across all pairs.
That's what I'm thinking.
Or you could still just manually search for the last one.
Fuck, why did I do that? Okay. So C23 BMN. So first of all, get rid of all of this shit. And get rid of all, I don't know. I had a key binding for this, but whatever, I don't remember it. Get rid of all that shit. Delete that. Delete this too. Does this work? And then yeah, I wish I had been thinking about the gate better. I hadn't been thinking of it like a physical gate, and so the way I was coding it was really strange. Um, should be something like this. So first, let's see if that's still working. Stop. Okay. Now let's try making our swaps, right? So I'm going to say for swap in out swaps. No, I'm going to say for A and B in out swaps. Gate 1 equals gate with output wire A, and gate 2 equals gate with output wire B, and then I'm going to swap these, right? I'm going to say gate with output wire A equals gate 2, gate with output wire B equals gate 1. Is that all I need to do? Or do I need to swap everything else too? I need to swap the gate op. No, I don't. I think this is literally all I need to do. Damn, I was really overthinking it.
Or you could denounce the sum's closer.
Man, I was really
Closer.
overthinking it. Oh my gosh. Yeah, it's like really close now. There's like 1 bit difference. It's right here. Is that the only bit difference? No, there's 3 bits of difference here.
Well, it's 1 bit difference. That's kind of called a carryover.
So it's this one. 0, hold on. Yeah, okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Fuck, I fucked it up. Whatever. Come on. For I B1 B2 in enumerate zip sum stir -1 rest stir -1 if B1 is not equal B2, print I. 29. So something's up to 29. Or, you know what? We could just try, let's just try every swap, right? Like,
Hello.
hello? Well, let's see if there's something obvious in 29 first. So Z29 is getting this XOR. That's good. But then maybe one of these is wrong, right? GQK. This part looks right.
Yeah.
So then let's look at WFR.
No, that probably looks right. I don't think 29 is wrong.
So you think it's but the other ones are higher.
Could be 28.
I was gonna say it could be 28. 28 could be carrying over wrong. What the fuck? Oh, what up?
So quiet.
Is this better? Hello.
Yes.
Okay. Do you think that I should do this today? have not done part
Which
1
is day 24.
Indeed.
Day 24 is being annoying.
I'll like solve part 1 and then like do part 2 with you if it's annoying.
I think I was just
I'm
thinking
gonna
right
want to
wrong.
do it.
You might have an easier time. I wasn't very
Alright,
familiar
I'll
with
do it, sure.
adders. The fuck was I doing? Alright, Z28 MGB.
SGD.
That looks right. That also looks right. MGV might be wrong. Or the carry might be wrong, but I don't know where that is. MGV and SCD goes into TDQ. Let's look at our formula again.
Yeah, I don't think I was wrong either.
We're gonna try and brute force it. We're gonna say,
Okay, is part 1 just like a recursion? I'm guessing.
for J and range, I was one like the thing. D2 J. What am I doing? Part 2. Or we could probably do this a little. Let's just say for like that, and then we'll say for J and range instead. You can say output wires equals list of gate with output wire, like that. I might even say couple. Yeah. Then I'm gonna say for I OW1 in enumerate output wires, and then for Jane range, output wires, OW2 equals output wires J, and I could say gate 1 and gate 2 equals, let's just copy paste this code right here. And let's replace, let's just call this A, I don't want to deal with it. Like this. Check. And swap back. Like that. Now all we need to do is say what's our check here? We need to check that sumster and rester are equal. Let's pre-compute all of these. Like this. Let's also pre-compute this. X, Y, and Z wires. Then to get our numbers, we just have to calculate this. Pretty sure we can pre-calculate this too. Yes. I think we can just do it directly like this. Try that. Then over here, when we do our check, we do it like this. Like that. Bruh. This is why I had the scene earlier, because some swaps make cycles. That's really annoying. Try like that, and then how do I check for the cycle? I need to say, I need to keep track of like a scene. I already had the code for this, I shouldn't have deleted it. Let's try this a naive way. I feel like I'm gonna run into the same issue I had earlier, but let's just try it. Because we might not, and then I don't have to do the work. Need monads.
There's an option type in Python, I thought.
But there's no, what do you call it? Like, there's no like a greater than. I don't remember what that's actually called. Like, you know, in Haskell you have the greater, like the do operator. There's no do operator. You get what I'm saying? You get me?
Without operators.
Like in Haskell, right? If I want to chain a bunch of maybe operations together, I can just use a do operator. I don't have to do unboxing and unboxing. I'm doing a bunch of unboxing here that I shouldn't need to, because I'm just propagating it upwards anyway. What the hell? Did I fuck up? What did I do? Okay, hold up. There should be a reverse equals true here or something, right? How was it working before though? Yeah, hold on. Let's. It's this shit again. Getting the nuns. The nuns, the nuns, the nuns. Okay. We're gonna go like this. We're gonna say this is the work I didn't want to do before. I should have just done it, but whatever. That looks right. Except now this might be too slow. Bro. Oh my god. Come on, man. That's annoying. Is this not correct? I have it a code, maybe whip out the pie a couple times. It's actually pretty easy to set up.
What? Pie?
Yeah.
G14 was your... No, wait, that's wrong.
That has to be wrong. That should be faster. Yeah, that was much faster. It's still wrong, but there we go. Why is it saying 14?
Could be, I guess. Did you try swapping them and see if that works?
Yeah, let's try that.
Or maybe the cards only printed out if swapping it actually gives you the right answer.
DCV C14. I mean, it looks right. Maybe my get val is wrong, but I could bring it back to the simplified one, and it should still.
Where did it actually give you the right bits?
Yes.
Oh, that's probably right then. You find your 4 swapped.
But so then, why did Advinico not like it? I don't know.
Oh, wait, did you try submitting it?
Yeah.
Oh. Yeah, I'm guessing the last error is going to be in the 30s. Probably between 32 and 37.
No. This is working. Right?
I mean, you'd have to try multiple inputs. Could just be working by chance on this one specific input.
Oh. How else are you supposed to check? Isn't that what the brute force is doing?
I think one input that. Well, I don't know. It might always be possible to wire it in a way that this specific input works while others fail. But if you try like all ones plus all zeros,
Let's try this.
that should.
Candidates equals this, right? And then I'm gonna say candidates dot append a b, right? And then instead of returning, I'm just gonna do all of them, and then I'm gonna print my candidates like that. Oh my gosh, except I already did the swap. Oh, hold on. Oh, I didn't. 1, 2, 3. Oh, these two are wrong. Okay. And we're gonna sit here, we're gonna wait for however many billion it is. It won't take too long, I don't think. I bet you it'll take less than 15 seconds. Yeah. There were multiple. How much you want to bet it's the one at the...
RDS and JSF might be the right one.
I was gonna say, I would think it's not the register. So...
Yeah, it's not Z14 if you looked at it. Let's look at these two. See if these are linked to one that's related to X30, to the X and Y that's in the 30s.
X14
No,
and
this is
Y14
X14.
RDS.
What's the other one? Because we know 14 most likely is an error spot. No, just check what the other one is related to. With the other JSS. Oh.
You want to say fuck it and try it? Bruh. Okay. But then I don't know. Because I feel like they all involve Z14 and that doesn't make sense. So
Yeah, I'm not sure why brute forcing doesn't give you correct answer. You can try building upwards then. Basically, you looked at all the Z's, and just by looking at the Z's, you found 3 of the pairs. Now look at the X's and Y's. You know that every X and Y should be XORed into some variable, and that variable should be XORed into the respective Z. And if you start with that technique, basically just looking at the X and Y's and seeing which one doesn't get XORed into the Z properly, you'll find the last one.
that sounds like it's gonna take forever.
You can also write a program that does that. But I'm willing to bet it's going to be between 32 and 37. Because you got one that's in the first 10, you got one that's in the next 10, you got one that's in the 20s. So the last one's probably in the 30s.
Ooh, hold on. This might be it. Right, X34 goes to GGN. GGN goes to Z34. X36.
Oh, right.
PBD. PBD is going into 36 and it should be going into 35.
No, it should end up going to 36.
No. Like, look, X33 goes to HSG. HSG goes into Z33.
33.
For 34 goes to QMR. No, this wrong one.
Oh, 35 going to 36.
34 goes into GGN. GGN goes into Z34. 35 goes into FPQ. FPQ goes into G35. But then
Oh, that's right.
oh no, this is right. Yeah. Wait, am I tripping? X36. X35. FPQ. FPQ. Z35. Yes.
Look at the X37.
PBD. PBD. C36. X37. HRN. HRN. Z37.
38.
TJS.
Also right. 39.
BRJ.
Yardage. And look in the 40s, I guess. Realize it. SCR. No. Where did you start?
30. Actually, wait. I should have known that it's before 29, right? From that. Your guess doesn't make sense. GQK.
I was going off.
I know I'm
Yeah,
going off,
but
but I'm
it's-
just saying it doesn't make sense for hours, right? G29. SCD. I think 23 is the one that's messed up. X23, XOR Y23 goes into QMD. But then QMD never goes into C23. So BMN and G23 should be swapped. Well, we already knew that. We already knew that one.